Welcome to Sundar's lecture. This is lecture number 19, and in this lecture we are going to see multiplexers, right? So what are all the topics we have seen in the previous class? See, we have started with the full adder using half adder with a two half adders and with an OR gate, right? And we have seen what is half subtractor, that means 2-bit subtractor, and full subtractor, 3-bit subtractor. We have drawn the logic diagram for both half subtractor and full subtractor, and we have gone for full subtractor using full subtractor using two half subtractor with an OR gate, right? So we have drawn the logic diagrams, right? So today we will see multiplexers, right? So multiplexers intends many inputs to one output, which means if you have many inputs and with those inputs you just need only one output, then this multiplexer will help you to get any one of the output from the many input, right? So that is what I've written here. From different inputs, the mux select any one to the output. So it is called as data selector. For example, you can directly say that it is 2 power n cross 1. And what is this one now? What is 2 power n now? 2 power n is the inputs, and this one, it is defaultly output. It is default output, only one output, right? And what is this n now? We need to know what is this n, right? This n we generally call it as selectors, right? So 2 power n inputs will be there and one output will be there, and this n which will give you the number of selectors, right? That is what we will see that. So for example, if I have 2 cross 1 mux, maybe I will write it as mux. So what it actually means now? What it actually means, I have two inputs and one output. Then how many selector switches you will have now? Maybe you can write like it is 2 power 1 cross 1. So this one, what is this one now? This is selector switch, selectors, right? So how this diagram looks like, it will be like this. This is a box, right? This is a box, and you have two inputs. See here, this is two inputs and one output now. One output. You have this one, right? So now, what is this one now? This is nothing but the selector switch. That means I will call it as S0, and I will call this as now Y, and I will call this as now maybe inputs. You may write it as whatever it may be. This is one input now. This is 0. This is 1. Try to understand, because you have one, right? So minterms, like minterms, you write it down. If you have if you select, if you give S0 to 0, then it will select this one. If you give S0 to 1, then it will select this one. So how it looks like, it will be like this one. Can you understand? So if you give whatever it may be, if S is equal to 0, then it will be select the 0 first input, and if S is equal to 1, it will select this one. So how truth table will looks like now? Maybe I will draw down. So maybe you see here, this is yes, the selector input, and this is now Y. Maybe I will take like this. So just to remember or to easy understanding, I will make this as D0, D1. So what will be the output right now? So if S is equal to 0, D0 will be connected to output. And if S is equal to 1, then D1 will be connected. That's all. Simply you can say like this, right? Now what I am going to do now, I will say it is 4 cross 1 mux. what it actually means as, right? It is 2 power 2 cross 1, right? Am I right or wrong? Right? So this one is what now? This is now the selector switch. Selectors. So how many selectors you will have now? Two selectors, right? So how the diagram will looks like now? So you have a mux like this, a mux like this, and you have one output that is default, and you have now four inputs, 1, 2, 3, and then 4 inputs. That is what I have written here, 4 cross 1. And you have now two selector switches, right? So this one, if you take it down, maybe I will write it as this is D0, D1, D2, and then D3. Maybe in general, what I will do now, maybe this is S0 and this is S1 now. Selector switches, right? So this is now Y. This is default. And you know that the switches will be connected like this, right? So what is this one? It is actually a 4 cross 1 mux, right? This is the diagram of the multiplexer, right? I generally write now, I always try to write this is 0 0 0 1 1 0 1 1. Why? Because I have two inputs here, right? So if I try to write the truth table like this, for example, if S0 is what, S1 is what, and Y is what, that is what I am going to do now. So if you do so, if S0 is 0 0, if I give 0 0 here, then which switch will be selected, then which input will be selected? D0 will be selected. And if I give 0 1, then D1 will be selected. Try to understand. That depends on selector switch, and whichever the input is going to connect it to output, that depends on the selector switches, whatever you are giving as an input to selector switch, right? And if I give 1 0, then it will be connected to D2, D2, and if it is 1 1, then it will be connected to D3. Output is connected to D3, and you can give either 0 or 1 from this input. Try to understand this inputs can be either 0 or 1. That depends on whatever you are giving there. Okay. Now this is the 4 cross 1 mux, and what we will do now, we will go for 8 cross 1 mux. 8 cross 1 mux. Then if it is so, then what is this one now? 2 power 4, right? 2 power 4, right? Sorry, 2 power 3 cross 1. So how many selector switches will you will have now? It is now selector switches, 3 selector switches you will have. So now how the diagram will be? You will have an 8 cross 1 mux now. So 8 inputs will be there and 1 output will be there. For example, this is my output. So 1, 2, 3, and then 4, 5, 6, 7, 8. Right. Now this will be how many selector switches? 1, 2, and then 3. This is my selector switches right now. So what it will be looks like. So this is actually D0, D1, D2. Maybe I will naming my inputs D3, D4, this is D5, this is D6, and this will be now D7. And now my selector switches will be S0, S1, S2, and my output will be Y here. And what is this one now? This is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And my switch will looks like this one. Now, this will be connected like this, right? Can you understand now? This is the diagram. What if I give the inputs like S0? For example, this is S0, S1, and then S2. And what will be my output now? This is the idea. For example, if I give 0, 0, 0, 0, 0, 1, and I will write it down. Right. Right now you see, if I give 0 0 0, D0 will be selected, right? So output will be now D0, this is D1, this is D2, this is now D3, and D4, this is now D5, and this is D6, 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 and this is now D7. Right now, this is how the output will be selected. And what is inside this 8 cross 1 mux now? See, for if it is 16 cross 1, then you will have D0 to D15, and you will have now 4 selector switches, right? So I am not going to draw that one. You just try to understand that one, right? So this is how 8 cross 1 mux will looks like. So this is actually 8 cross 1 mux. Anyhow, right, what we will do now, what is inside this one, that you need to understand, right? What is inside this one? See, I will draw the diagram first and I will explain you. Right now you listen me. What is inside the max? That is what I'm going to draw here. See here, you know, right, the truth table is like 0 0 0 and the output will be D0, right? So what I'm giving now for this AND gate, I by default I will give this as a D0 now, D0. And what will be the inputs? How you will connect this one? So for example, you connect this S0 to this one, to this one, this S0, and then S0 bar, and then S1 bar. Why I am doing this one? Try to understand. I will explain you bit later. And S2 bar, and S2 bar now. So what happens now? This one will be connected to this OR gate. Will be connected to this OR gate. For example, see here, if I give 0 0 0, then what happens? This S0 bar becomes 1, and this S1 bar becomes 1, this S2 bar becomes 1, and that is what these three are connected to this AND gate now. And I have also given D0 to this AND gate now. Then what happens now? If 0 0 0 input has given to S0, S1 and S2, and S0 bar, S1 bar, S2 bar is now 1, that is given to AND gate, and whatever you have given in D0, now it will be transferred to the OR gate. Why? If I give 1, then everything is 1, so AND gate output will be 1. That will be connected to OR gate. So if OR gate gets 1, the output will be 1, simply. If I give D0 as 0 now, all the 3 inputs is 1, but this is 0. So AND gate output will be 0, and that 0 will be connected to OR gate will produce a 0 now. Try to understand, right? If this is 0 0 0, then all other AND gates will be disabled. I will explain you a bit later, right? So this is the whole idea. So what I will do now, I will try to connect all the AND gates. Right. Now you listen me. This is what the multiplexer will looks like, right? This is inside the multiplexer. What I have done, I have explained you this D0 input, right? If it is D1, then what should be the thing, right? So what should be the thing? It will be 0 0 1, right? So 0 0 1 means what? D1. So it is 0. So S0 bar should be connected, and again 0 S1 bar to be connected, and it is S2 should be connected now. So what happens now? If you give 0 0 1, then this AND gate will be enabled for 0 0 1, and whatever you are giving for D1 will be taken as the output for taken as output from this AND gate, and it is connected to OR gate. For example, if you give a 0 here, it will be transferred. If you give 1 here, then it will be transferred. Try to understand, right? If you know the principle of AND gate, and it will be very easy, very simple too. So this is what multiplexer will have. For example, if it is a 2 cross 1, then you will have 2 AND gates. We have 3 cross 8 cross 1, then you will have 8 AND gates. 16 cross 1, you will have 16 AND gates, and 1 OR gate will be there. So this is the general block diagram or logic diagram inside the multiplexer, right? So you try to draw for other 16 cross 1, 4 cross 1, and whatever it may be, right? So I've just given you the basic idea about what is the logic diagram inside the multiplexer, right? Now what we will do, we will try to solve problems of Boolean expression using the multiplexers. Right. Now listen me. This is implementation of Boolean expression using mux. What you need to do, you have to implement this Boolean expression, right? This is actually Boolean expression. They have given you in min terms, and you need to implement this expression using 8 cross 1 mux and also 4 cross 1 mux. Then what you will do now? Simply, I try to draw the diagram now. Try to draw the truth table for this particular Boolean expression. how the truth table will looks like now. I will draw it down. Right. See here, this is the truth table, right? So for 0 to 6, 7, so this is min term 0 and min term 2, min term 6 and min term 7 are 1. This has 3 inputs, right? So 3 input system, and we have 8 number of combinations. That is what I have drawn here. So what is this one now? You need to implement this with now 8 cross 1 mux. So 8 cross 1 mux is how now? It will be like this, right? So you will have a multiplexer. That means one output is there. 8 cross 1 means one output will be there and 8 input will be there, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 input will be there. And how many selector switches you will have now? 1, 2, 3. 3 selector switches you will have. So what is this one now? So this is actually min term 0, min term 1, min term 2, min term 3, min term 4, min term 5, min term 6, min term 7. In sense, I generally written in the basic explanatory, it is 0, 0, 0, 0, 0, 1. I am just writing it like min terms, right? Now this is now y. And now what is the selector switches you need to write? This is the selector switches, right, to understand. Now A, B, C are the selector switches. A, this is B, and then this is C. Right to understand. Now, what is the thing? It is very easy, very simple. Maybe your diagram will be looks like this one, right? So the thing is, what you do now, you have both 0 and 1 is there, right? This is now 0, this is now 1. And what you need to do, you have to connect all the ones wherever you need. So you see here, this is 1, you connect this one to here, and then to 2 you need to connect, right? And then to 6 you need to connect, right? So to 6 you need to connect, and then 7. These 4 are ones. That is what I have done here. I have written here. And what you need to do, you have to connect this one zeros to this one. This is 0. This is 0. This is also 0. And this is also 0. Try to understand. Now what happens? If I give 0, 0, 0, 0, 0, 0, this switch will select this input, right? 0. And what is in 0? I have given it as 0. So I will just write it down. This is now 1, 0. This is 1, 0, 0, 0. This is 1, this is 1. Try to understand. That is the input I have given. That is the input I have given. Now this will be connected to 0 and the output becomes now 1. Try to understand, right? So what is this one actually? It is 8 cross 1 mux. 8 cross 1 mux. And if you give 0, 0, 1, what happens? This is connected to 1. 1 is what? 0. That 0 will be connected to output. See, try to understand. We have just implemented. Even if you check it out for 1, 1, 0, 1, 1, 0. So 6 will be connected. 6 is 1, right? So it will be connected to output. Try to understand, right? This is how the Boolean expressions can be implemented using 8 cross 1 mux. And the thing is now, they are asking you to implement also with the 4 cross 1 mux. How this is possible? That is what we are going to see now. How we can implement this expression with 4 cross 1 multiplexer, right? Now see this one. This is now 4 cross 1 mux, right? So 4 cross 1 mux. And I am not going to draw the switches also, right? So this is now Y. So now this is S0, S1. Don't put S0, S1. This is now put A. This is now B. Why? I will tell you, right? So I will have C separately here. So I can give A, B now, but I don't give C here. Why? How I need to give C? That is what we are going to implement now. See here, how many inputs you have here? Only 4, but you have 8 combinations here. So what you do, you just connect, you just put a line here, also here, and also here, right? Now what you do, and also here, right? What you do, we don't need to see for this one. A and B I have already connected, so you don't need to see that one, right? So what you do, you just try to compare these two. These two is what? This is 0, this is 1, this is 1, this is 0. So you need to compare output with the C input, and you can see that it is inverted, right? If it is 0, it is 1. If it is 1, it is 0. So what you do? You write it as C bar. The output, right? The output is C bar. And you see here, this is 0, 1, this is 1, 0. Again, it is a C bar. You see here, this is 0, 1. Whatever the input of C it may be, the output is what? Defaultly it is 0. So it is 0. And it is 0, 1. Whatever the input in C, you have default 1. So it is 1. Simply what you do now, put this as now C bar, this as C bar, this as default 0, this as default 1. And what you need to do now? Now you have to connect from C, put a NOT gate, and you connect here. Connect the same NOT gate here. And this has to be connected to, this is 1. This has to be connected to default 0, and this has to be connected to default 1. And now you check it out now. For example, if you have 0, 0, 0, I give 0, 0, 0, 0 can be given here, 0, 0 can be given here, and this is now 0. What happens now? This selector switch inside this one, maybe I don't have any space to draw. Anyway, there is a selector switch. The selector switch will select this one, right? This is 0, this is 1, this is 2, and this is 3. If I give 0, 0, it will select 0. If I give 0, 1, it select 1. If I give 1, 0, it select 2. If I give 1, 1, it select 3. That is the idea, right? So if I give 0, 0, obviously this 0 can be now connected to output. That is default. But what is the input given to this one? This is 0. The C is 0 here. So this C will be inverted, and this will become what now? 1 here. So that one will be connected to output. That is what here you try to understand. Try to understand. Now, for example, if I give 0, 0, 1 here, maybe this will become now 1. Right? This will become now 1. That is the second input, right? That is the this input, and the output should be 0. How? 0, 0, 1 I have given here. If it is 0, 0, then again my selector switch will select this one, this input, and this is 1. That is inverted, and it will be 0 now. This 0 will be connected to output. What is this one here? You see here, both are satisfied. For example, if I give 1, 1, 0, we will take this one now, 1, 1, 0. So 1, 1, 0 means what? This is now 1, 1, right? This is now 0, right? What happens now? If it is 1, 1, then obviously this selector switch will select this one, third pin, right? Because 1, 1. So third pin will be selected. Try to understand the concept of mux. So what is here now? This is default 1. This one will be connected to output. This is satisfied. So if you check it for any other outputs, this will satisfy now. This will satisfy now. Try to understand, right? This is the whole idea, right? This is the whole idea, right? Right now you see here, I have just taken this. The second problem is implement full ladder using 8 cross 1 and 4 cross 1 mux. What you will do? You take this truth table, that this is the truth table of the full adder, right? So what you do now, this is for sum. Actually this one is for sum, and this one is for carry. You have to draw two separate because you have two outputs, right? So you have to draw two separate marks. So what you do now, you just take this as now A, B, C. This is now A, B, C. This is output sum. This is output carry. And what you need to give for this midterms, right? That is what I am going to do now. See here, this one, it is 1, 2, and then 4, 7 are 1. So 1 is 1. This is 1. 2 is 1. And 4 is 1. 7 is 1. All others will be what? 0, 0, 0, 0. You just connect this one. That's all. Try to understand. And for carry, 3 is 1. So 3 is 1. 5, 6, 7 is 1. So 5, 6, 7 is 1. All others are 0, 0, 0, 0. That's all. That's all we have implemented. Try to understand. If you give ABC as 0, 0, 0, what happens now? You just common, this is common, right? So you can write ABC and give to all the this for this one and for this one. Right, now if we give 0, 0, 0, then it will select this 0, first input. So the sum will be 0 as well as the carry will be 0. If I give A is ABC as 001, then it will be selected in this mux, this will be selected, and everything is very simple here, right? So this is how you need to implement a full adder using 8 cross 1 mux. And for 4 cross 1 mux, what you need to do? That is what we are going to do now. Right. Right. Now you listen here. So I have taken this one. Right. This is the truth table of the full adder, and I have just drawn for sum separately, carry separately with 4 cross 1 multiplexer. And what you need to do, AB is common. AB is common. And you have to compare the C now. So I have already told you, right? So how to do this one. So what you do now, you take this one because you have only 4 outputs, right? So this one, and this one, and this one, right? So what you do now, you go separately for sum and then separately for carry. Try to understand. You have to compare for sum separately. See here, this is 0 0 1, so 0 1 0 1. So for sum I will write it down here, and for carry I will write it down here, right? So anyhow I will extend this one, extend this one, extend this one, right? So what you do now, first for sum you write it down, first for sum, and then you write it for carry. So you see here, what is the thing here? This is 0 1, this is also 0 1. So for sum the C will be same. First this is C, right? So this is C. C will be same. And you see here, this is 0 1, this is 1 0. So it will be now C bar. And this is 0 1, this is 1 0. Again it will be C bar. This is 0 1, this is also 0 1. So it will be C. Write it for carry now. For carry, you see here, this is 0 1. By default it is 0, right? So this will be now 0. This is 0 1, this is also 0 1. So it will be C. This is 0 1, this is also 0 1. So it will be C. This is 0 1. By default it is 1. By default it is 1. Now I have found all the values. Simply what you do now, you just write this is C. For sum I am writing this is C bar, and this is also C bar, and this is now C, right? This is C, right? That is what sum will have. And for carry, it is 0, it is C, it is C, it is 1. Simply, right? Now what we have done now. So you can connect this one. Maybe the C input is here, you just put a NOT gate and connect it down here. And you don't need NOT gate here. Anyhow, you need a NOT gate here. I don't have space, so you do this one. So what we have done, we have just implemented the full adder using 8 cross 1 as well as 4 cross 1 multiplexer, right? So what are all the topics we have seen in this class? See, we have started with the multiplexers, right? So we have started with the multiplexers. And what is multiplexer? Multiplexer is many input to one output. So you will have many inputs, and how many inputs you will have? 2 power n inputs cross one output. And what is n here? N, which is nothing but it is the selector switches. For example, you have 2 cross 1, then it will be selector switches will be 1. If it is 2 power 2, then it will be 4 cross 1, then the selector switches will be 2. And like that, we have seen 8 cross 1 mux, right? So this is the 8 cross 1 mux, and what is the truth table of this one? And also we have seen what is inside the multiplexer. Inside the multiplexer, you have logic diagram, and this is the logic diagram, right? And we have seen how to implement Boolean expression using the multiplexers, and we have seen how you can implement the Boolean expression with the reduced multiplexer, right? With reduced number of inputs multiplexer, and we have implemented using adder using the multiplexers, right? You try to implement subtractor using multiplexer, right? That is the case study you may do by yourself, right? So we will see in the next class with the demultiplexer, encoder and decoder, right? Thank you.